As we continue Chapter 5, we're going to do multiplication now. And we'll start off with key terms here very shortly. But we're going to be multiplying monomials and binomials, multiplying any two polynomials. We're going to be introduced to the FOIL, which is a special way to multiply two binomials. We will square binomials, get the products of sum and differences. These are sometimes referred to as special products. And again, throughout this, we'll be doing function notation. Some of the students had mentioned that they actually do the matching before they watch the video, which is a good idea. So let's take a look at it now. For letter D, the differences of squares. So there's a square, and there's a negative sign. The differences of squares. Now, the FOIL is this one, where you will do the first and get this, then do the outers and get this, then do the inners and get this, and then do the last. So the letters are for first, outers, inners, last. Now for number 3, when the first term is squared and the last term is squared, and then you have double, as you see here, this is called a perfect square trinomial. And that'll be one of the topics we go over. And then the product simply implies that you are multiplying your P times Q and your X times X. It implies or indicates multiplication. Now, what we want to do here is to, again, go over techniques and strategy. So this is only one example, but you're going to use this for many. So here, this is negative, and in a sense, this is a monomial out here, and this is a monomial there. So you're multiplying a monomial by a monomial. So what will your sign be? Well, it's going to be negative. Then 2 times 5 will be 10. And then now you're going to add your exponents. There's a 1 there and a 2 there. So this is going to be x to the third, y to the fourth. No particular sign here, but now this is a monomial by a binomial. So you're going to distribute the 10t. So this becomes 30 t cubed. Now you have to watch the sign, negative 70 t squared. Now, as we look at this, an interesting note would be that going this way, this is the distributive principle. But if we had this and went back that way, remember that word? That would be factoring. Now, we're going to show you 2 methods for this, but keep in mind that eventually when we multiply a binomial by a binomial, we're going to use the FOIL. Which is first, outers, inners, last. But there is another way, and in fact I'll use the other way on this one, just to show you the two ways. So for our FOIL here, we're multiplying our first. That will give you an x squared. We're going to now do the outers. That's going to be a negative 9x. We're going to do our inners. That's a positive 4x. And then we're going to do our last, which is a negative 36. Now, notice often when you do the FOIL, your two middle terms are like terms. So you're going to go from a four-termed polynomial to a three-termed polynomial because you're going to combine these. So your final answer here would be x squared minus 5x minus 36. Now another thing to note is that later we're going to take something like this, which is a trinomial, and factor it to its two sets of binomials. That is the opposite of multiplication. We're going to factor this trinomial. Remember, this trinomial is a product, and it came about from multiplying two binomial factors, which produce this, that we then did the combining like terms into this. So we will look later at techniques to undo the FOIL, which is factoring. Now, for this method, and this can be used generally, depending what you're comfortable with, for multiplying a binomial, you would go 2a minus 3, and then underneath it you would put 4a minus 5. Now what we're going to do here now is multiply using this, what we call long multiplication. So we go this term times this term, watching the signs, gives us a plus 15. Now this term times this term gives me a negative 10a. Now this term times this term is going to give me a negative 12a. Now notice where I'm putting it in its like term column. And now this one times this one gives me a positive 8a squared. So I've set up a little pattern where I multiply, then develop like terms, and now I just add them. 8a squared minus 22a plus 15. So this is another way for you to use multiplication of a binomial by a binomial. Now there's still another way actually, and I should show you that just so you have it as among different strategies. That is, you take the first term of the first binomial and multiply it by the second binomial, and it looks like this: 2a times 4a minus 5. Then you take the second term of the first binomial, negative 3, and multiply it by this: 4a minus 5. Now you distribute, and you get 8a squared minus 10a. Then you get a negative 12a plus 15. And then you group your like terms. 8a squared minus 22a plus 15. And you might say, wow, these are the same. Exactly. Now, this is called over here the horizontal method because it's all horizontal. And I call this one, or many call it, the vertical method. They get the same thing, two different strategies, along with another strategy. You could have used the FOIL. And you want to be familiar with all of these. In some cases, one will work better than the other. The key is to get the right answer. Now, again, I'm going to strongly suggest that you do a binomial multiplied by a trinomial using the vertical method. Now, you could also have done it horizontally. But this way, again, you're getting your like term columns, and it's much easier, I think, to get the correct answer. So this times this times this, watching the signs. Putting them in their like term columns and then adding them up. So this one, again, the very same way, a trinomial by a trinomial. So looking at number 10, a trinomial by the trinomial. And remember, you could have this one on top, that one on the bottom. The results come out the same. So carefully watching the signs. Negative times a negative gives you a positive. This gives you a positive. This gives you a negative. And then going through each line. And notice this example, you have like 4 or 5 or 6 examples in here, because multiplying each line, you have to get the correct signs and the correct product, and then lining them up in correct like term columns, and then finally carefully doing the signs. So something like this, you'd want to double check to be sure you're getting the right answer. Now in this next one, it's rather interesting. Again, we're going to do it vertically. And we see when we multiply this first item by the trinomial up there, we get this, being very careful of the signs. And then when we do this one, we get this. And notice this then cancels out. And we're just left with this. This, by the way, is called the difference of perfect cubes. And the difference of perfect cubes actually factor into this here. Again, that's something that you'll be doing in the next course, but here we're actually seeing that if we multiply this, we get this, and in a way, it's a proof of something you'll be doing later. Okay, let's take a look at strategy now. For example, 12. Now, what's your strategy here for doing this? Well, I would think you'd want to FOIL these first two. So let's do that. X times x will give me x squared. Now my outers, I'm going to put here as a negative x. That's my outers. My inners a 2x, positive 2x. When I do this addition or subtraction, I'm left with a positive x. And then my last is a negative 2. So I'm doing a FOIL in which part of what I'm doing it mentally. And hopefully as you work the FOIL, you will be able to get some speed and do some of it mentally. That's what you are shooting for. So first, x squared. Outer's a negative 1, inner's a positive 2, which leaves you with a positive 1x. And then last, a negative 2. And now you put your next term, x plus 5. And you actually do this. And there we see, again, using the technique, the vertical multiplication, the trinomial on top, the binomial, then multiplying each term carefully, watching the signs. And as you may have seen over past videos, if you're watching all of these, every once in a while I make a little error. And I don't know, hopefully they're not purposeful, but sometimes a silly thing. I'll say negative and it should be a positive. And as I may have told you orally, that when you find an error, remember the time down at the bottom there. There's usually a time. And say, oh, at this time, pause the tape and I'll give you a bonus point. There you go. Bonus points are always a good thing to have as needed. All right, I'm going to clear this up so we can work on this next one here. Now, in this next one, we are doing something that's called squaring a binomial. Now, one way would be just to write this binomial again and then FOIL it. But this is considered what is called a special product. So a special product has a special way of multiplying, and it's something you should be working on. And the recipe, and I'll give it a couple times, is you square this first term. You then multiply these two terms together, and you're going to get a negative 6a. Then you're going to double it, that is, multiply it by 2. So you get a negative 12a. And then you square the last term. Now a negative 6 times a negative 6 will always be a positive. And in this case, it's 36. Now, one of the words we had in our original matching was a perfect square trinomial. And that's what this is. This is a perfect square trinomial that came from squaring a binomial. So when you square a binomial, you get a perfect square trinomial. Now notice your two end terms are perfect squares, and your middle term is the doubling of what you have here. And that sign is also crucial. There's a negative there, then this middle term will have a negative. Now this next one is just tedious. Again, you could either FOIL it, which would be difficult, or set it up vertically. So we'll skip that one for now. And this one is a perfect, well, it's a binomial that we're going to square. So let's do this technique. Square this. 5a times 5a, 25a squared. Now multiply these two together. You get a negative 20a. Now you have to double it. and then you're going to square a -4 and a -4. Again, it's always going to give you a positive, and in this case is 16. So what is this called? A perfect square trinomial that will factor into a binomial square. The first and last terms are perfect squares. If you take the square root of this, you get a 5. You take the square root of that, you get a 4. 4 times 5 is 20. Double it, you get your middle term. And that is the recipe. Again, this one's a binomial that we're going to square. So we're going to square this first term. Squaring 2 gives me a 4. And then this becomes a 4, and this becomes a 10. Going to multiply the 2 times 7, get 14, double it. That gives me the 28. And notice we have a plus for our middle term. And then this part stays the same. X squared 5y, or y to the 5th, I should say. Then we're going to square the 7, and we get a 49. All right, number 17 is giving us some function notation, where they're saying the function of x here, p of x, which is this, and q of x, which is that. Find, multiply the function of x, p of x times q of x. You're just going to multiply these two terms. That would be the strategy. And you would set it up vertically, and we've done some like this. Now, for number 18, all they're asking is to take this f of x and square it. So you're going to, in a sense, they could have written it this way, but they want you to see it in function notation. So this is equivalent to this. So we're going to use that special technique. Square this first term. 1/3 times 1/3 is 1/9, x to the second. Then for our middle term, we're going to multiply the 1/3 x times a -8. So 1/3 x times a -8, and there's an x here at the end, of course. And then we're going to double it. So this becomes a -8 over 3. Then 2 times a -8 gives you a -16 over 3. And then, of course, the x is there, which I forgot to put there as well. And then you're going to square -8. -8 times -8 is a positive 64. So again, this is higher level math, but as long as you know how to do it, that's what we're trying to show you here. We're going to do a little review now of what we have been doing so far and what we did in class. Here we have special products. That is, when we're going to multiply, we get special things. And we mention this in when we square a binomial, and I see I have a little error there. There you go, that's better. When we square a binomial, we square the first term. That gives us a squared. We multiply these two terms together. That gives us an ab. Then we double it. That gives us our 2ab. Then we square the last term, and we get a b squared. Now, if this is a negative, everything is the same except this sign would be a negative. And this is a perfect square trinomial. And the key to this is that a perfect square trinomial factors into a binomial squared. Now, another special product is this one, where we have the sum, which is a plus, and the difference of the same terms. So the product of the sum and difference of the same terms, and these, by the way, have a special name. They're called conjugates. This is the conjugate of this, and vice versa. So it'd be the same terms, but opposite signs. They are called conjugates. Conjugates. Now, when you FOIL conjugates, notice what happens. The first, you get a squared. The outers, a negative ab. The inners, a positive ab. The last, a negative b squared. Notice your two middle terms cancel out, and you're left with just a squared minus b squared. And this, you recall from our matching at the beginning, was called difference of perfect squares. Oh, well, what's the key here? Well, if you have the difference of perfect squares, they will factor into its conjugates. And if you recognize you are multiplying conjugates, you know you're going to get the difference of perfect squares. The middle terms cancel out. So let's take a look here. Look at number 19. A plus 10, a minus 10. These are conjugates. So when you put your answer, it's going to be a squared minus 100, because your inners and outers are going to cancel out. Notice these are conjugates. So you're going to get 25 x squared minus 9 y squared. You don't have to worry about doing the inners and outers because they're going to cancel out. These are conjugates. Take a look at it carefully. U to the 10th minus v squared w squared. So they're giving a little higher math here, but they are conjugates. And this is a kind of a funny mix here. Let me get back to you on this in just a moment. And what I wanted to do here is to show you that these can be rearranged. Remember, we can, through the commutative principle, just switch that around, and I get this. And now they're more in the form that we're used to. So this would be 49 x to the 4th minus x squared y squared. Again, some of this is a little heavier math. We're tending not to get to the too difficult. We're still trying to keep this basic to middle as opposed to super hard. Speaking of some of the more complicated ones, we're going to pass this up a little bit. Well, we'll do this next one because this is sort of like a closure thing. Here's a binomial that we're going to square, which we did here. Here is the difference of perfect squares. Once we FOIL these conjugates, we had our negative sign outside, change each of these signs internally, and there's our answer. So it's not too bad. It looked a little daunting in the beginning. Now this is conjugates, and this is squaring a binomial, and you add like terms. But I don't believe I put this last sheet in your booklet, so we're going to call it at this time, which I'm going to try to keep these at about 30 minutes. So good luck, and again, get your practice and your quiz bees done.